So we are talking about powers of a monomial. I've already defined what a monomial is, right? A monomial is a product of variable or a constant. So we talked about this here, like for example, 3x, that's a monomial. 3 is a monomial. 5 by itself would be a monomial. 5xy, that would be a monomial because it is a combination of a variable and a constant, just a constant by itself or just a variable, right? But as long as nothing separates them, like here, this will not qualify as a monomial because it's no longer just one term, you're adding them, right? So we define that in early on in chapter 9. Now today we're going to talk about powers. We've also done a lot of things with powers. But the one thing that you need to know now is how do you compute the power of a power, right? How do you compute the power of a power? So that's what we're going to learn now. This is a monomial here, right? I have x, and x is raised to the power of a. And then the whole thing is raised to the power of b. So how do you compute that? How do you evaluate that? That's what we're going to learn in this chapter, okay? Now, this is just symbols. I'm just telling you what it is. Now I'm actually going to give you an actual example. For example, I have 3 raised to the power of 2. The whole thing is raised to the power of 5. And I'm asking you to evaluate that. So how would you do it? So this is 3 squared raised to the power of 5. So how do we find that out? So to do that, we're going to use the rule that we just learned about. X raised to the power of a, the whole thing raised to the power of b. So how do you do it? You multiply the exponent. That's all you're doing. All you have to do here is multiply the exponent, right? So 3 raised to the 2, the whole thing raised to the 5 is equal to 3 raised to the 10 because 2 times 5 is 10. Okay? So how come you guys have nothing to write about? You guys are just staring. And then later on you're going to tell me that we don't understand this. Okay, doesn't matter. You still have to write this down. You don't want to do it, then don't come to school. So that's the only option.
I would go to jail.
Right? So this is 3 to the 10. Okay? So
I would be a juvenile detention right
so
now.
basically, this is called the power of a power, right? So 3 raised to the 2, for example, if I have 2 raised to the 5, the whole thing raised to the 6. And I want you to evaluate this. So how would you do this, Gabriel?
You'll do like, I don't remember. You'll do like 2 to the power of 5 and then raise it.
So what did I say? I just mentioned the rule here, the way you're listening. Right? Did you see what I did here, right? 3 raised to the 2, the whole thing raised to the 5. So what do you do to the exponent? It's on the board. This is adding?
I mean, no, you multiply.
You multiply it, right? So that therefore, how would you do this here? 2 raised to the 5, the whole thing raised to the 6.
You'll do 2 raised to 30.
2 raised to the 30, that's right. This is 2 raised to the 30 because all you're doing is you're multiplying the exponent, right? So this is how you do this. So 2 raised to the 5, the whole thing raised to the 6, it's going to give you 2 raised to the 30. Now let's try something else here. What if I have x to the 4, the whole thing raised to the 5? So what would I give you? X to the 4, the whole thing raised to the 5. What does that give us? X to the 20, right? Because all we're doing is multiplying the exponent. 4 times 5, that is 20, so it's x to the 20. Okay? All right, now the next one, I have 4 to the 3 raised to the 7. And I want to evaluate this. So what's that going to give me?
4 to the 21.
4 to the 21. Does everybody know how we did that? Kenzie, you get it? 4 to the 3 raised to the 7.
Oh, yeah.
That's
4 and then exponent is 21.
21. So all you're doing is multiplying the exponent. Again, this is called the power of a power, right? So this is how you do that. Now what about y to the 4, the whole thing to the 4? And I want you to find this.
Y to the 16.
Y to the 16, right? Y to the 16 because you're multiplying this. Now we have something with a negative exponent. I have 2 to the 3rd raised to the negative 2. Kenzie, what's that going to give you? 2 to the 3rd raised to the negative 2. Yeah.
Oh, I just noticed 2 negative 6.
2 negative 6. And remember what we did in a very, like two sections ago? When we have a negative exponent, how do you write it by getting rid of the negative? What do we do? You all remember? Who remembers how to do this? When you have a negative exponent. Anybody want extra credit?
You do it.
So they never do it the other way.
How do you do it?
You take it and you put it like 1 over
Right.
2 to the 6.
That's
and
right.
then
So
will
that becomes
equal
1 over what?
1 over.
2 to the 6, right? Which is basically
Oh, yeah,
1 over 64, right? So anytime you have a negative exponent, you have to flip it. You never keep a negative exponent. You always have to turn it into a positive exponent. So that becomes 1 over 2 to the 6, which is 1 over 64, right? So that is how you do it. So I'm going to put twice here so I know that you're good. So that's extra credit right there. So I want you to remember this thing, okay? All right, so that's called the power of a power. So let me give you another example. What if I have x to the negative 3, the whole thing to the negative 10? What would I give you? X to the negative 3, the whole thing to the negative 10. X to the positive 30, right? Do I need to make any changes here? No. What if I have y to the negative 2, the whole thing to the power of 7? What do we get?
Y to the negative 14.
Y to the negative 14, and then what?
1 over y negative 14.
1 over y to the
14.
14, not negative, right? Positive, because we want to get rid of the negative. So anytime you have a negative exponent, you want to make sure you turn that negative exponent into a positive by flipping it, right? According to the rule that we learned in the last 2 sections. All right, so that's called the power of a power. Now we're going to stretch it a little bit. Now we have what you call the power of a product, right? The power of a product. And what does that mean? Here, I don't just have one expression. I have xy, right? xy, and xy is raised to the power of m, okay? So when that happens, each entry is going to be raised to the power of m. What do I mean by that? So if I have here 5x to the 7, right? 5x, the whole thing to the 7, because the expression is in parentheses, that means 5 is going to be raised to the 7, and x is also going to be raised to the 7. Does that make sense? Right? I have two things here. I have a 5, which is the constant, and I have the variable x. And the whole thing is raised to the power of 7. So this becomes 5 to the 7 times x to the 7. And the rule is called the power of a product. Okay? First thing is this. We have the power of a power, and now we have the power of a product. So you have to do it for each of those pieces in the monomial. So example, I have 3x to the 3rd, right? 3x to the 3rd is raised to the power of 4. So if you do it, what's going to happen? Let me do it here. I have 3x to the 3rd, and now it's raised to the power of 4. So what's going to happen here? What's that going to give me? Yeah, go ahead.
Raise everything to the power 4.
So tell me what you're going to get.
3 to the power 4
Mhm.
times x to the power 3 times
3 times 4, right? Because x has a power of 3, and based on what we learned earlier, because this is a power of a power, you have to multiply the exponent, right? So that gives you 3 to the 4, and then x to the 12. Now, when you have numbers like this, like 3 to the 4, we know we can find what it is. 3 to the 4 is what? 3 times 3 times 3 times 3. That gives you what? 81. Okay? So this is 81 x to the 12. Okay? So this is how you use the power of a product. Now, I gave you a couple of things here that I want us to try together. Okay? So let's do them one at a time. Let's do them one at a time. So the first one is, we have 6w 4 raised to the power of 5. So go ahead and try it on your own and tell me what you got. So we have 6w to the 4 raised to the power of 5. And you see how you're going to apply that product rule. 6w to the 4 raised to the power of 5. Are we done?
No.
30 more seconds. repeat. You done? Alright. So, alright. So expand. So what did you get? How did you do it? Yeah.
So I did the power of product thing,
Mm-hmm.
and I got 6 to the power of 5 times w to the power of 20.
That's good. That's good. And then what? And now we can find 6 to the power of 5, right?
Yeah.
So 6 to the power of 5. What did I give you?
I got 7,776.
That's what
7,776.
Yeah.
All right. So this is 7,776 w to the power of 20. Okay. Now let's try the next one. I have -4. Let me write down here. -4 x to the 5 y 7 the whole thing to the power of 3. So let's see what you get on there.
And he's like, no.
It's just, okay, yeah.
So -4 x to the 5 y to the 7 and the whole expression is raised to the power of 3.
You can't say that.
All right, let's see. 45 more seconds. Done? Have you done?
Yeah.
So what did you get? So tell me what you, so go step by step.
I added -4
Mm-hmm.
power of 3,
Okay.
and I added x to the power of 15,
15. Mm-hmm.
and y to the power of 21.
All right, does everybody agree with that, right? It's -4 to the 3rd power, x to the 15 because 5 times 3 is 15, y to the 21 because 7 times 3. Now, what do we do with -4 to the 3rd power?
Do it,
Mm-hmm.
turn it into you do the conversion.
You do the conversion thing, so you
with
do
Oh.
one over.
Do we do the
No.
conversion here?
Oh, you don't just
No.
you just put it in the format.
Format. So what's
Okay.
-4 times 4 times 4? What does that give you?
-48.
-48? You sure?
Yeah, it's
16 times 4, that's 64, right?
Yeah.
So that's -64.
Oh,
And it's -64 x 15 and then y 21, right? So it's -64 x 15 y 21 because this is an odd number and this is negative, so you're gonna get a negative, right? So it's -64 x 15 y 21. Yes.
So when you have like a negative exponent and you put that in that format that we did a while ago,
Mhm.
do you do the whole conversion or do you just put it in that format?
You just put in that format. Let's do it on that. The
Alright.
next one. The next one has that, right? Let's do that for the next problem.
You can't raise something to a negative power.
So we have 3x to the -2, right? Y to the 4, and then the whole thing is raised to the power of 2. So let's see what that gives us. 3x to the -2, y to the 4, and then the whole thing is raised to the power of 2.
Two times two is 4. Yeah. Never in that here.
That makes it both of us. So far so good, but you need one more transformation. You're almost done. All right, are we done yet?
Just give me a minute.
All right, a minute. I give you 20 seconds.
Actually, a minute.
I don't know how to solve this.
I think I got it right. I'm not sure.
All right, so tell me what you got.
This looks like gibberish.
Mm-hmm.
I got 3 with over 2
3 to the 2, okay. And then what?
times x and -4,
Okay,
and then times y 8.
8. All right, so far so good then. What else do we need to do here?
To the
Mm-hmm.
the
Yeah,
it's 9.
okay, 9. Mm-hmm.
And then I did the inversion because it's like negative,
Inversion, okay.
and then times y 8.
1 over x to the 4 like this, right? Times y8. All right. Now, I mean, technically this is right, but we have to go a step further, right? Because this is 9. We can multiply what? 9 times 1 times y8. Okay? So because 9 is like 9 over 1. Okay? So that gives us what? 9 y8 over x4. Okay? So this is in the denominator. So you're going to 9 times 1 times y8. So this is 9y8 over x to the 4. Okay? So this is how you do this here. Okay? Okay, now we're gonna finish and close this with a word problem. You know what a cube is, right? How do you find the volume of a cube?
You have to do like a.
You do what? You do what? Let's do it.
Height times base. Is the height times base
Okay,
times
let me write it again. I'll write it again.
So it's base times height. I got it. Right?
You got it?
Yeah, it's base
Alright.
times height, so it's width.
All right. Now let me show you something here, right? To find the volume of a cube, the volume is pretty much s to the power of 3, right? S to the power of 3. S stands for what? Side, right? So side raised to the power of 3. So because all the sides of the cube are the same, they are congruent, right? They are all the same. So therefore, to find the volume of a cube, you just take one side and you cube it. Okay, you raise it to the power of 3. This is the formula to find the volume of a cube. Now, I gave you the length of one side. So now how are we going to apply what we learned today to find the volume of a cube? So what are we going to do?
That length.
The length, which is what? 2
Yeah, all
x
that raised to the
y5
power of 2.
raised to the power of what?
2.
3.
3.
Volume.
Well, I thought you would have to get the side, you would have to multiply that by itself.
Now, this side, all of them are the same. They're all congruent.
Well, side to the power of
3. Yeah, to
So
find the
wouldn't
volume.
that be one panel of the side?
No, that's one side, not the panel. Just one side, this side here, right? So you do length times width times height. Well, the sides are the same because it's a cube. So therefore, to find the volume of a cube, you have to just raise the one side to the power of 3. So what do we get? If you expand this, what's that going to give us?
Oh, 2 to the third, x
Okay.
to the third, y to the 15th.
Y to the 15, and then we
And
go
that's
further.
8.
That's 8.
8 x to the third, y to the 15th.
Right to the 15, right? So this is how you apply this rule here. So we learned two things here today: the power of a power and the power of a product, and then we apply it to word problem. Okay? Want to find the volume of a cube? You can use this formula to do it. You can simplify it because other people are gonna go this times this times this. Too much work. I'm just gonna do it quickly. I'm just gonna raise it to the power of 3 because the lengths are the same.
That was such a word problem. That was such a good word problem.
That was such a good word problem. All right, so now I want to give you work.